So the root form for a quadratic is written by y equals a times x minus d times x minus e. So if you put in some different numbers for a, d, and e, you'll end up with a different equation each time. For example, one that we might look at is y equals 2 times x minus 1 times x minus 3. Okay, now remember, if we want to graph this, the first thing that we want to find, let's say it is the y-intercept. So remember, the y-intercept is when x is equal to 0. So everywhere in this equation I see an x, I'm now going to write a 0. So y equals 2 lots of, so 0 minus 1 is just minus 1, and 0 minus 3 is minus 3. And so here I end up with a y-intercept of just 6, so 0, 6. Now, next up are my x-intercepts, or sometimes referred to as my roots or my solutions. In fact, we call this the root form because it's really easy for us to find our x-intercepts. Remember, in the standard form, it was a little bit trickier. We had all of those different techniques. Here, it's actually rather straightforward. Remember, this is when y is equal to 0. So we get our x-intercepts when y is equal to 0. So we take our equation, our 2 times x minus 1 times x minus 3, and we need that to be equal to 0. Well, it's already factorized for us. So we just, here, x can be 1, or from this bracket, x can be 3. So we get the root 1, 0, and we get the root 3, 0. Now, next up is the line of symmetry, or our turning point. And these guys are going to sit exactly halfway between the two roots, right? Because this graph has to be symmetrical. So if you think of a parabola to be like that, and let's say our axis is here, well, we've got a root here, and we've got a root here. So our line of symmetry and our turning point has to be exactly halfway between our two roots. There's nowhere else for it to sit. So because we're in the root form, we will always have at least one root, okay, often two roots. So our line of symmetry in this case is just going to be exactly halfway between 1 and 3. So that's going to be at 2. And then to get the turning point, we just put this x equals 2 into our equation here. So we get 2 times 2 minus 1, which is just 1, and then 2 minus 3, which is minus 1. So we end up with a y coordinate of minus 2. So our turning point is at 2, minus 2. So if we were to sketch this, so if we remove my little sketch over here, if we were to try and sketch this graph, our y-intercept is at 0, 6, so that is here. Our x-intercepts are at 1 and 3, so that is here and here. And then our line of symmetry is going to be exactly halfway between those two roots, because this thing has to be symmetrical, with our turning point being on that line of symmetry down at minus 2. So that's going to be that bit there. And then if we wanted to, we just connect these markings and we end up with a parabolic shape for our quadratic equation, which is what we should expect. And if you had a bit of graph paper or something with a nicer scale, you would get a more accurate, a nicer looking graph. Let's look at another example. So it might be y equals -3 times x plus 2 times x minus 4. So remember, the y-intercept, that is just when x is equal to 0. So everywhere I see an x, I just put a 0 in. So -3 times 0 plus 2 is just 2, and then 0 minus 4 is just minus 4. And well, we end up with positive 24 here, sorry. So 0, 24. Okay, so that's the y-intercept. Let's look at my x-intercepts, or my roots, or my solutions. Okay, so it's called the root form because this step is far much easier than the standard form because it's already been factorized for us. So remember, it's when our equation here is equal to 0. So when our y value is 0, we get our x-intercepts. And so if we were to solve this, we can see that that's going to happen either here when x is -2, or here when x is 4. So we get the coordinates -2, 0 and 4, 0 for our x-intercepts. Now for the line of symmetry, that is going to have to be exactly halfway between the two roots. So between -2 and 4, exactly halfway between those would be at 1. So when x is 1. And then for our turning point, we just put when x equals 1 into our equation. So y is -3, and then 1 plus 2 is 3, and 1 minus 4 is -3. So we end up here with positive 27. So a turning point of 1, 27. And if we were to graph this, we have our y-intercept all the way up at 24, so that's quite a long way up, okay, all the way up there. So that was our y-intercept, I'll highlight that. Then we have our x-intercepts at -2 and 4, so that might be here and maybe out here. Our line of symmetry, which is halfway between those two roots, so it's going to be at 1 here. Okay, so that line of symmetry there, that's at x equals 1. And our turning point sits on that line a little bit higher than our y-intercept, all the way up here at 27. And because of this negative number out the front, we would expect that this would be a sort of a sad face parabola. So if we connected these dots, we go up and turn and back down the other way, we get a sad face parabola. We'll look at one more example, and this is where there's only one root. So let's go for y equals 2 lots of x minus 2 all squared. Okay, so this again is in the root form, because I could also write this if I wanted to as y equals 2 lots of x minus 2 times x minus 2. So let's start off with our y-intercept. So that's just when x is 0, so y is 2 times 0 minus 2 all squared. So 2 times -2 squared. So we're going to get 8 there in total. So we get a y coordinate of 0, 8 for our y-intercept. If we want to find our x-intercepts, or our roots, or our solutions, so remember this is when y is equal to 0. So we now need to solve for when 0 is equal to 2 lots of x minus 2 squared. Or in other words, we need to solve for when 0 is equal to 2 x minus 2 x minus 2. And what we see from our null factor theorem that both of these brackets give me the same answer, that x can be positive 2. So I get kind of what we call a repeated solution, or a repeated root. I just get my x is equal to 2 pop out. That means for my line of symmetry, that's going to have to lie on my root. I can't go halfway between two roots because I've only got one root. So my line of symmetry is also at x equals 2, which means my turning point happens when I put x equals 2 into my equation. So y equals 2 times 2 minus 2 squared, which of course is just 0. And that has to happen because our x-intercept is at that point, which we expect to have a y-coordinate of 0 if we're on that x-axis. So a turning point of 2, 0, which is the same coordinate we get for our root. So our root and our turning point here are actually the same point. So if we came over and we sketched this, we have our y-intercept up at 8, so that's that point there. So we can mark that all the way up here. We have our x-intercept at 2, so down here. And that is also our turning point and lies on our line of symmetry. We know that this is going to be a happy face parabola, just by the symmetry of it. If we're going to turn, we have to turn here, but also the fact that we've got a positive number out the front. So if we were to connect this, it would go something like that, and then just reflect it out the other side symmetrically. And that is what our parabola is going to look like. That's pretty much it for the root form. It's a little bit nicer than the standard form, I think, in as much that it's already factorized for us, so we don't have to do things like completing the square or slide and divide or quadratic formula or anything like that. Really, we can just read the roots straight off the page. And the bonus is that the line of symmetry, turning point, and y-intercept are also not too hard to find. So I think it's a nicer form than the standard form.